Hi everyone, so we're going to start on exam 4 practice problems. We're going to start with question 1. So this one is an option A, option B problem. So let's read through the instructions and then we'll get started. McIntyre's Eye Clinic is considering investing in a new optical scanning machine. It has two options. Option A would have an initial lower cost but would require major repairs at the end of the third year, so that's kind of important. Option B is more expensive, has slightly higher annual maintenance costs, but does not require a major overhaul. Also has a salvage value, at the end of its useful life. Its useful life is 6 years, and our company's cost of capital is 14%. So we have some numbers here that we're going to want to keep to the side, so I'm actually going to just do it like this. Hopefully you guys can see that. So at least you can see option A, then we'll move it over. So option A, so that's this top one. I kind of labeled a little table here. If you want to pause the video and do that, that might be good. So the first thing we want to do, I like to work left to right. So I don't like to do one and then do it all. I like to just do all of them at once and work that way. So let's start with the years. So the optical scanning equipment, we're going to buy right now. So that's a now. I just write now, just so I know. Some people put year 0, but I just like now. We have annual cash inflows and outflows, and we know that the amount of years that we have for the useful life is 6 right here. So we're just going to do from years 1 to 6 for both of those. Okay, then we have a major repair that they said is going to happen at the end of the third year. So I'm going to put a 3 right here. And then the salvage value is at the end of the 6th year, but that's not really for this option. We'll see that in a minute, but we're only dealing with option A, and option A doesn't have a salvage value. So the first thing we want to do for the amount is the optical scanning machine. Oh, and now I'll pull this back over. The optical scanning machine is going to cost $100,000 to put in right now. Okay, and so now we want to move down to the annual cash inflows, and that looks like it's going to be $56,000, and because it's an inflow, it's positive. And then we have an outflow. So because it's outflow, we're paying the money for something that's going to be negative, so negative $24,000. And then finally we have a major repair, and that's also going to be an outflow, because if I'm repairing something and I have to pay for it, that means I'm losing money. Okay, so then what you would do is you're going to go into your book and you're going to get some sort of PV factor on your test, so don't worry about that. But I have them to my side here, so I'm just going to use these numbers. But basically, because we know that it's 14%, and we know the period, so we know these right here, we can determine what the present value factor is. So anytime anything says now, that means we actually don't even have to present value it, right? So that means we're just going to multiply it by 1. It's already in its present value. So the next two are annual cash inflows and annual cash outflows. So this is going to be on a different table. This is going to be on the annuity table because this happens every year. So that's annuity and annual. That's a good way to remember it. So we're going to have to use that different table. And another way to remember that is that the values are just slightly higher than just the single year. And so what we're going to do is we're going to take the last period in that for that annuity. So for that number, what I found was 3.889 for both of those. And just so you know, I accidentally put this wrong on the solution initially. So there's a correction online for that. So now we're going to do the major repair, and this is the same thing, but we're going to go to the other table, right? Because it's not annual, we're just going to go to that initial table. So the initial table, we're going to go to 14% into the third period, and that would give us 0.675. Okay, so now this is nice and easy set up for us. We're just going to multiply across. So this is what I get. I got a negative 100,000. That doesn't change, right? This one is 217,784. Then we have a negative 93,336. and then we have a negative 35,775. Okay, then let's add all those up because that'll get us our NPV of the entire investment. So add it all together, I get a negative 11,327. Okay, so now let's do option B. So some of this is actually going to be the same. We'll just carry it right down, which is really nice. So our year, I'm actually going to do these really quick. So year amount, PV factor, and PV. So the year, we can just copy these down. They're just the same, right? So now we have years 1 to 6, years 1 to 6, 3, and then 6. But the thing is about this major repair, we're just gonna not do that because the option told us we didn't have a major repair on option B. The initial investment is going to be a little bit more expensive, so it's actually going to be $160,000 this time. So that's negative, right? Because we're spending the money. Then we have a cash inflow every year of approximately $60,000. Oop, not a parenthesis. That's positive. Now we have a cash outflow of $25,000. My bad. Yep, 24,000. Oh no, goodness, 25. I'm sorry. Cash outflow of 25,000. And then it's telling us at the end that we're going to get a salvage value of 24,000. So that means we can sell it for 24,000. So that's going to be good for us because we might get some of that initial investment back. So the PV factor, also the same as above, which is nice, except we're going to have to find a new one for the 6. But 3.889, 3.889. And then this last one is going to be, we're going to go to that 14%, go down to the 6th period, and that present values to 0.456. That's our PV factor. And then we're going to multiply everything across just like we've been doing. So that's going to give me a negative 160. And then I have 233,340. A negative 97,225, so slightly different than above. And then we also have that present value of 24,000. This is new to us, and that's a 10,944. Okay, so then same thing as above. We're going to add all these together, and that gives me 12,941. Okay, so we did the very first part, so we just did this calculate the net present value of the optical scanners. Now we want to decide which one we want to purchase based on our answer to this above one. So what we want to do is we either want to go for the option that'll give us the option that's going to give us the most return, right? So we want to go for the investment in this situation that's the lowest cost to us. So the higher number. So the least negative. Sometimes we get confused because if this was positive, this would look higher, right? But this is actually the higher number. So just make sure we're double checking on that. So the answer for number 2 would be that I wanted to pick option A because we always want to pick an option that's going to give us a higher return and it's going to cost us less money. So this one's going to cost us less. And that's probably not very eloquently worded, so sorry about that. So the next one, we want to go to what other methods of evaluating capital projects did we discuss in class? This is kind of something different. So we also talked about, I don't know if you guys remember this, but we've talked about payback and simple rate of return. And you'll see in this little practice exam, we just kind of want you to know that we discussed them. I don't think you really need to know too much about them. Okay, so then question number 4. Why is the net present value a better method than these two above methods? So the reason is, just to explain it kind of briefly, I'll write out the answer. So it takes into account the time value of money. Wow, I have really bad handwriting. Sorry about that. Okay, so the reason is because if we present value everything, we can get a more accurate idea of what these cost right now and what it's going to mean to us right now. So it's basically like your dollar today isn't worth as much as your dollar, or is worth more than your dollar is worth tomorrow. So that's kind of the idea of time value of money. I'm sure you've heard that in other classes, but so we can incorporate that by using this present value method. So that's it for this question. We'll come back and do the remainder of the practice problems.